Hi, Wansing, is it? Okay, you're the only one for lesson today. Um, you remember where we left off last week? We did matter, right? Wansing? Okay, I need you to be interactive today, because it's gonna be me and you. If you keep quiet all the time, then lesson's gonna be very boring. Okay, Wansing, Can you do that for me? Can Okay, so what we're gonna do today is you can see a blank screen on the right, on your computer, right?
Yes.
Okay, so we will start with revision. Okay. And then after that, we will actually do, if you recall last week, we stopped after the MCQ. We didn't do the open-ended section. Do you remember?
Yes.
So we will finish up the open-ended, then we will do today's worksheet. I think we will have enough time. Can we do that? Okay, so you recall from last week's lesson, matter. What are the states of matter that we learned last week? What are the three states? Let's see, what are the three states of matter? Huh? Yeah, I said you need to participate. If not, I don't know how lesson is going to go on. So what are the three states of matter and sing?
Solid.
Solid. Next one.
Liquid.
Good. And finally, what's the last state? Solid, liquid, and
I forgot.
you forgot. Gas. Okay. Can remember solid, liquid, gas? Okay, Ken? Hello. Okay, so if you recall, matter is anything that has and occupy. Can you fill in the blanks? In order for something to be considered the matter, it needs to have this and it needs to do this. Do you remember?
Yes.
What is the first one? It has what?
Mass.
Very good. So mass is like weight, right? You either use a beam balance, the thing that tilts like a, what do you call this? Seesaw, correct? Or you use something like this, then you can attach things here, then it will tilt according to the heavier side. Or you use a weighing machine or a scale, correct? To measure mass. Okay, what is the next one? What else must matter have? No, what else must?
Occupy
Very
space.
good. Very good. So when something occupies space, I'm actually talking about its volume. Correct, Wansing?
Yes.
So usually I taught the class last week to measure a volume of an object like with that doesn't have a definite shape. For example, if I want to measure the volume of a nail, what I can do is first I have amount of water, let's say 10 ml. Correct? Then I am going to put the nail inside the water. And what will happen to the level of the water? Will it go up? Will it go down? Or will it remain the same?
Go up.
Good. So maybe the new volume of water is now 20 cm cube. Okay, instead of ml, let me change it to cm cube. Give me a while. So this is 10 cm cube. Okay, so can you tell me the volume of the nail? What is the volume of the nail?
cm.
Good. So I take 20 minus 10 is 10 cm cube. So what I can say is the nail occupies space and displays the water in the beaker. Okay, so you must remember the word displace. I will keep repeating the word displace. This is a key word in the topic of matter. When I mention displace, I mean something takes the space that was previously occupied by another thing. So for example, if one thing now you are sitting on the chair, okay, and maybe I come over and push you off the chair, and then I sit on the chair. That is me displacing you off the chair. Can? So anything that occupies space can displace the object that was previously in that position. Can? Once you understand? Good.
Yes.
Okay, so now let's talk about solid. Okay, solid. The three things that whenever we talk about matter, okay, we need to consider its shape, okay, and whether or not it has a definite volume. So we need to consider definite shape or no definite shape, definite volume or no definite volume. So for solid, does it have a definite shape? Does it have a fixed shape?
Yes.
Good. So first thing, okay, solid has a definite shape, which means on its own, okay, its shape is fixed. Unless, for example, I hammer it, I use a force, then I can change the shape. Very good. Okay, let's talk about liquid. Does liquid have a definite shape, Wenxing?
No.
Good. So please remember liquid has no definite shape. So we did a question last week. Okay, I will just quickly show you this one. This shows that liquid has no definite shape because it can take the shape of whatever container that it's in. Good. Okay, the next one, gas. Does it have a definite shape?
No.
Very good. Also no definite shape. So I gave an example to the class last week when I blow balloons. We know balloons come in different shapes and sizes, right? So the air will also take the shape of the balloon. So that shows that liquid and gas both have no definite shape. Okay, let's talk about volume. Does solid have a definite volume?
Yes.
Good. So solid has a definite volume. When something like solid has a definite volume, can it be compressed?
No.
Yes. So when something has a definite volume, it cannot be compressed. Very good. Okay. So if you think about my cup, cannot compress, right? So good, solid. Now, let's look at liquid. Okay. Does it have a definite volume based on your memory? Try.
Yes.
Have or don't have?
Yes.
Good. So it has a definite volume. Very good. You remember. So liquid also has a definite volume, which means same thing cannot be compressed. Okay. So, okay, I will talk about this later. Let's move on to gas first. Finally, does gas have a definite volume?
No.
Very good. So gas is the only one that has no definite volume, meaning that it can be compressed. So if I have a container, okay, that is 100 cm cube. The size of this container is 100 cm cube. I'm going to pump in 200 cm cube of air. Will the air be able to fit inside the container, Wen-Xin?
Yes.
Yes, it can, because the air can be compressed. Okay? One other thing I want you to remember is, let's take another look. I have another container. Okay? Now, this container is 200 cm cube. Inside already got air. All right? And then question says, I'm going to add in 50 cm cube of air. So question asks, what is the final volume of air in the container? What is your answer? What's your answer, Wen-Xin? I have 200 cm cube of air in the container. Then I add in another 50 cm cube of air. What is the new volume?
250.
Oh, a lot of people make that careless mistake. Remember what I said last week? Air will occupy available space in the container. What is the available space in the container, Wen-Xin? What is the available space in the container? How big is the container?
200.
So the only space in the container is this. Correct, Wen-Xin?
Yes.
That means air will only take up 200 cm cube. No matter how much air I pump in, I repeat, no matter how much air I pump in, it doesn't matter. The air will just fill up 200 cm cube. Can you please remember that? So the final volume is still going to be 200 cm cube. No matter how much air I pump in, it will always remain as the available space in the container. Means the air will always fill up whatever available space is in the container, no matter how much air I pump in. Wen-Xin, do you understand?
Yes.
So even now, okay, if I let the air out, if I let out 100 cm cube of air, what is the amount of air inside the container? So if I let out 100 cm cube of air, right, Wen-Xin? Question asks, what is the final volume? What is the final volume? Remember this. What is the final volume? Can you try?
100.
What is the available space inside the container, Wen-Xin? What is the available space inside the container? Hello, what is the available space inside the container?
Two hundred.
Huh? Can you repeat that? I didn't hear it.
200.
Good. So if the available space is 200, even if I let out 100 cm cube of air, how much air will there be in the container? Wen-Xin, how much?